The submersion caused significant corrosion here. We need to reinforce the aft section immediately.
Roger that. Prep the mobile cranes to remove the number 2 engine pylon. Are the hydraulic lines connected on the left wing?
Almost. We're showing green on sectors 3 and 4, just waiting on the pressure test.
Look at the state of this wiring harness. 30 years underwater took its toll.
It's worse than we thought.
Avionics systems check complete, ready for the lift sequence. Acknowledged, cockpit clear, crane diving operations commencing now.
The avionics connections are heavily corroded.
Diagnostics confirm unstable readings. We need to detach this panel immediately.
Try running the diagnostic sequence with this device.
Okay, uploading the parameters now. The optical relays seem stable.
Check the connection on auxiliary power unit line 3.
This schematic shows the stress fractures here. We need to reroute. Significant corrosion along the rear fuselage frame. We can replace the spars, but the avionics conduits are a concern.
The stress analysis on the wing assembly junction is showing red flags right here.
Yeah. We need to prioritize that structural scan before we authorize the lift sequence.
The hydraulic lines in the left wing assembly are compromised.
Confirmed. We'll need to reroute the primary lines through the auxiliary channels.
This yoke assembly looks correct based on the 3D scan.
Yes, but the interface panel still needs modification for the new avionics. The avionics upgrade requires rerouting these conduits through the main spar.
Can the existing infrastructure support the increased load capacity?
Stabilize the load. Lift on my mark.
Hold positions. We've got structural fatigue right here. Mark that damage for immediate assessment.
Cross-referencing this harness with the schematic.
The diagram confirms the routing, but the damage is extensive.
Log everything before we proceed.
Loosen the main coupling now.
Copy that. Applying torque.
Panel F-17 is clear for removal. Stand by to receive it.
All right, clear the hydraulic lines on section 4.
Disconnecting the junction box now.
Confirmed. Structural integrity looks compromised right here.
We need to log this hydraulic assembly before removal.
Reading confirmed. Submitting the report now.
All right, bring it down slowly. Watch that coupling. Confirmed.
Avionics systems check. Initiating test sequence now. Telemetry stabilizing, but modulation is erratic.
Isolate the relay circuit before the power cycle.
Voltage drop is consistent across the auxiliary bus.
The primary flight computer is responding within parameters.
Cross-reference with the hydraulic sensor output. We need to check the MTBF data.
Check the oscillation dampeners on channel 3.
Readings are stable, Captain, within acceptable parameters.
The avionics systems are responding well to the stress test.
Telemetry confirms stable readings across the board. We are good to proceed.
The stress test results look good here.
Hydraulic pressure is stabilizing within tolerance.
Confirmed, we are green across the board.
The sensor readings are fluctuating here.
Let me compare that against the baseline specs. It might be within tolerance.
Final torque applied to coupling 9.
Reading confirmed. Mark the checklist complete.
Torque that connection to spec. Confirmed. Applying final tension now.
Systems check shows green across the board.
Confirmed. Avionics are fully operational.
Ready to engage the primary connector.
Confirmed. Engaging now. Secure that clamp.
Connection stable. Powering up avionics.
Is that feed secure?
Torque set to 20 foot-pounds. Connection verified.
Conduit 59er Delta secured.
Confirmed. Moving to the next harness.
Conduit connected. Initiating system check now.
Reading stabilizing on auxiliary power.
Diagram confirms continuity on line 7.
Check the resistance reading on connector 3 Charlie against the schematic.
It's slightly high according to the manual specs.
We should reseat the harness and retest before we call it in.
Check the relay switch reading right here.
Pin 5 is secured. Continuity confirmed.
Reading checks out. Documenting the repair now.
Testing the inertial navigation system connection now. Looks stable.
Confirmed. Power levels are nominal. That circuit is restored.
All right, bring it down another foot. Holding steady.
Clamps engaged and locked.
All right, steady the boom. Watch that cable tension.
Tension looks stable. Go ahead and lock it down.
Locking clamps engaged. Thumbs up. Clamps engaged and locked. Harness is secured. Ready for transport. All green up here, Chief. Thumbs up. Lift it steady. Keep it coming left.
Hold it there.
coming up on the locks. Bring it down slowly, watch the clearance. Holding steady on the left. Locking pins engaged, satellite secure.
Hold it right there. Engage forward locks.
Forward locks engaged, engaging rear locks now.
All locks green. Pallet secured.
Lowering the pallet now, watch your spacing. Clear on this side. Avionics, confirm power stabilized on the nav system.
Connection secured on the primary conduit.
Power levels nominal. Proceeding with system initialization sequence.
Is the antenna connected to port 3? Connection secured, running the torque check now. Feeder cables are routed and tied down, ready to close the panel. Align that bracket precisely. Torque sequence initiated.
Sequence complete. Gauge reads aligned.
Verified, good to go. Clear the ramp area, powering up the hydraulics. All personnel accounted for. Deployment looks good. Guide it down slowly now.
Confirmed. Avionics are online and stable.
A, SATCOM 1 is green across the board. C, comms check complete. B, solid link established.
Check the primary navigation conduit connection in Bay 3. Confirmed. Harness secured and labeled.
How are the diagnostics on the radar stabilization?
Showing nominal readings across all frequencies, Commander.
Structural integrity after 30 years submerged is astonishing.
And these modernized avionics integrate seamlessly with the original design.
The reinforcement plating is exactly as documented in the final mission reports. It truly showcases its durability under extreme conditions. The impact of the Globemaster on strategic airlift cannot be overstated. The technical innovations here are remarkable. The data plates here confirm the modification timeline. And this section aligns with the diagrams from the 90s.
The sealant application on the fuselage is holding up perfectly.
The thermal resistance data confirms that. I'll make a note of the structural integrity.
The cargo bay seals look good.
Agreed. Now let's move up to the flight deck. I want to check the communication suite integration. Note the serial number on this panel here.
This gear mechanism is clean, but the cable housing needs reinforcement.
Look at the wear right here on the gear mechanism. Good catch. We should prioritize that replacement before the next phase.
Inputting the pressure test results now. Everything is within spec.
Good. Good. Let's secure the panel and sign off the inspection.
Stabilizer surface shows only minor imperfections. We're clear for the next phase.
All right, make sure you document the stress points around the rivets.
Check the connections on the primary control board.
Everything looks secure here. Let's run the diagnostic loop again.
Initiating the system self-test sequence now.
All primary indicators are green, looking good.
Finalizing the report on the tablet.
Disconnecting the primary harness now. Module is free, ready for extraction on your mark. Confirmed. Lifting the unit clear.
This is the primary input for the comm suite. We need to ensure the shielding is intact here.
Okay. I'm getting a clean reading on the tablet now.
We've verified the avionics systems are fully operational.
Good. The cargo handling inspection is underway, documenting performance now.
Bring it up slowly. Watch the clearance on the starboard side. Holding steady. Almost there. Easy now. The lift right there. We need to check the alignment on the strut. Confirmed. Alignment check initiated.
Seals on the cargo door look good from this angle.
Steady now. Bring the aft section left, slowly. Easy now. Center line needs to be perfect.
Almost there. Inch it forward.
Holding position. Engaging bolts. Make sure that connection is tight. Bolt secured. Moving to the next bracket now. Check the alignment on your side.
All right, let's secure these bolts. Torque set to 50.
Hydraulics are aligned and ready.
Fasteners engaged. Moving to the next section. Position the actuator. Ensure precise fitment.
It's set. Applying torque now.
Verified secure. System is green.
Engage the press right there. Watch the pressure gauge.
Engaging hydraulics. Pressure is climbing. It's free. Retracting the tool.
Steady the frame, we're applying torque now.
It's breaking free. Extraction is a go.
All right, easy back, hold position at bay 3.
Removing the last hydraulic line now. Should clear in 5.
Clear on the left wing, keep her coming straight. Clear on the right, and stop. We are centered. Alignment check is green, bringing her forward now. Copy that. Watch the clearance on the tail.
She lives! 30 years, and she flies again.